Hello learners, welcome back to SOIM program on information technology applications in libraries. In last class we discussed about database management system. Today we are going to learn what is data models. Here we are having different types of data models. So we will be going to discuss what are the various features of these data models. Learners, let us discuss on what is a data model. A data model is a conceptual representation of data, including its relationship with the rules that govern how it is used within an organization. It provides as a blueprint for data structure, organization, and management of data. A data models in a database management system are frameworks that define how data is saved, structured, and modified within a database. So these models will give a clear structure of data design and the implementation, and also guaranteeing that data is handled very effectively and accurately. What are the advantages of data models? A data model provides a clear and precise representation of information. How this information has been stored in that particular database management system, from the data model you will be very much clear how this data has been represented in the database management system, and they will assist in identifying data gaps and minimizing the redundancy, as well as the data models will enhance the data security and the integrity of the data. The disadvantages of data models, we can say the complexity of database can render a data model challenging to the comprehend. Now let us discuss what are the different data models. There are two major data models. One is object-based model, another is a record-based data model. In the object-based data model, we have the entity relationship model, enhanced entity relationship model, object-oriented data model, object relational data model. So there are four models are under the object-based data model. And the record-based data model will have the hierarchical data model, network data model, and the relational data model. And the other models including semi-structured data model or NoSQL data models. Hi learners, now we are discussing on entity relationship data model, ER models. The ER model is a high-level data modeling approach used to define data and their relationships. ER provides a conceptual design and makes visualizing the data structure very easier. The entity relationship model was proposed by Peter Chen in the year 1976. Chen introduced the model to help design and represent the structure of databases more intuitively by mapping entities, attributes, and relationships. So that is already we discussed what are different components of ER models. Sorry. Now let us see what are different components of ER model. One is entity, attributes, and relationship. The entity means it is a real world object such as a book or a member or an author or a librarian or a publisher. So that is what we calling as an entity. In the given ER diagram, entities are shown as rectangles. Attributes describe characteristics of an entity like title, ISBN number, publication year, etc. This represented as ellipses in the diagram. You will find it here. Relationship. Relationships illustrate the connections between different entities that are depicted as diamonds or rhombuses in ER diagrams. Okay, so these are the three components of ER model. Learners, next is enhanced ER data model. Enhanced entity relationship diagram are advanced models that capture the requirements and the complexities of more intricate databases. So, ER model is an abstract representation of a database structure that defines entities within the databases and attributes associated with those entities and relationships between the entities. Whereas enhanced ER model extends the ER model to handle the complexities and requirements of more intricate databases. So it retains all the concepts of the standard ER model while introducing additional features to address more advanced structures. The ER model incorporates all the elements of the standard entity relationship model while also introducing the additional concept to address more complex relationships. The ER model includes the following concepts like subclasses and superclasses, specialization and generalization, category or union type, and attributes and relationship inheritance. Now let us see another data model, object-oriented data model. The object-oriented data model, the ER model focus on the defining entities and relationship with the simple attributes. But the object-oriented data model can be viewed as an extension of the entity relationship model by adding object-oriented concepts such as encapsulation, inheritance, polymorphism, and complex data types to the traditional ER model. So this object-oriented data model is also an extension of ER model, but we are adding some object-oriented concept into it. The another model is a object relational data model. The object relational data model combines the features of the object-oriented data model and the relational data model. It allows you to store complex objects as a part of relational database, leveraging the power of relational databases within the flexibility of object-oriented programming. The ORDM extends the relational model by adding object-oriented features like inheritance, polymorphism, and encapsulation. The next model, this is a record-based data model. The record-based data model, we all discussed. The hierarchical data model is one of the important data model there. The hierarchical model was first proposed and developed by IBM in the late 1950s and early 1960s. It was a direct result of IBM's effort to create a more efficient way to manage data on the IBM 7070 and IBM 360 series of mainframe computers. In a hierarchical data model, the data is organized in a tree-like structure as shown in the figure, where each record has a single parent record and potentially multiple child record. Next model is network data model. The first implementation of this model was by Honeywell in the year 1964-65 as the IDS system. This model is an extension of the hierarchical model, allowing for multiple parent segments grouped into levels with logical associations between segments at any level. Typically, many-to-many relationship exists between any two segments in this model. So it is very clear from the picture how this network model data structure. Next one is the relational data model. The relational data model is a method of organizing data in a database using a set of tables called relations. You will find in the figure how this data attributes have been related, connected as a relationship link. Each, it is clear from this figure, each table consists of rows, tuples, and columns attributes, where each row represents a record and each column represents a specific attribute of the data. Data in one table can be linked to data in other tables through primary keys. It's a unique identifier for rows. And foreign keys. It is a attribute that reference primary keys in other table, enabling relationship between different data sets. This model emphasizes data integrity, efficient querying using structured query language, and normalization of reduced redundancy. Data manipulation in RDBMS is performed using this structured query language. Structured query language is a standardized language for querying and modifying the databases. Next is semi-structured data model. The semi-structured data model is designed for handling data that does not conform to the rigid schema requirements of traditional structured data models, such as relational data models, but still it contains some organizational elements. The semi-structured data lacks a fixed schema but has tags or markers that organize elements and enforce a loose structure, making it more flexible and adaptable to diverse types of data. XML is a common format for semi-structured data. It uses tags to define the data elements, and the structure can vary without predefined schema. NoSQL database initially standing for non-SQL or non-relational. These databases are a category of database management system designed to accommodate a variety of data models that do not strictly adhere to the tabular schema of traditional relational databases. The key feature of NoSQL database is the ability to handle unstructured or semi-structured data, which is increasingly prevalent in modern applications. NoSQL databases are increasingly adopted in scenarios requiring rapid development, agile methodologies, and real-time analysis, where traditional relational databases may face limitations. Their ability to scale horizontally, support various data types, and provide high availability makes them a valuable options for modern data intensive applications. So learners, let us conclude. Data models are essential for proper design and functioning of databases in a DBMS. They provide a structured approach of database design from high-level conceptualization to detailed physical implementation. So understanding this model is crucial for database professionals to create efficient and reliable database management systems. In conclusion, data modeling is a fundamental process that shapes how data is structured, stored, and accessed within the information systems. Effective data modeling not only improves data integrity and reduces redundancy but also enhances system scalability and flexibility. As organizations grow and the data needs evolve, a well designed data model provides a foundation for adapting to new requirements, integrating additional data sources, and supporting advanced analytics. In an era where data is one of the most valuable assets, data modeling helps to ensure that this asset is well organized, accessible, and optimized for strategic use, making it indispensable to the success of modern information systems. These are the references. So, dear learners, let us finish today. And I thank all of you for your patience listening. And we will meet with another lecture in next class. Thank you very much.